Okay guys, so this is for your Module 1 review. Module 1 review notes is the packet you should have in front of you. So if you need to pause the video and go get it, please do that. Okay, so we're going to fill this out, and this is just some notes to remind you of what we've done this module. The first thing says constant of variation. This is your K, and it is always y over x. Your equation uses the K, and you put y equals whatever that number is, whatever that y over x is, that K number, you put that here times x. So for some examples, find the constant of variation and write an equation. So two things to do. So my constant of variation is always y over x. So these are my y's, these are my x's. So I pick a point, and I can pick any point that is where these dotted lines meet. So really any point on this line will work. Let's say I chose this point. The x is 16, the x is 16, and the y is 12. I can use this point, and I can do 12 over 16, but I need to reduce it. So another point I could use if I wanted to is 3 over 4, and that is what 12 over 16 reduces to. So that's my K. And then my equation, I use that K, I use my 3/4 times whatever my x is. So that is my equation. Okay, pause the video and try number 2 on your own. Okay, so now I'll go over number 2. If you have not tried it on your own, pause the video and try it on your own. And then come back and check your work. So, here is the first point. Yes, this is when x is 7, but I'm not exactly sure what that y value is. It might be 4.5, I don't know exactly. So I would rather use this point up here, 14, 9. So my K is y over x, 9 over 14. Now I think, does that reduce? Is there any common factor between 9 and 14? No. Then I write my equation. Y equals 9 14 x. From a table. The process is the exact same. My K is still y over x. And I can pick any of these pairs of points. These happen to be not in order, which is funny. I can pick any of the pairs. So I'll just pick the first one. And now I need to think, is this reducible? Can I reduce this? Yes, I can divide them both by 5. And I have 7 over 1, or 7. So my equation, y equals 7x. So this is my constant of variation. And this is my equation. Okay, again, pause the video and you try number 4. Welcome back. If you have not tried number 4 on your own, pause the video and try it on your own first and then come back and check your work. So we'll start with our constant of variation, y over x. Pick any pair. It doesn't matter. 21 over 24. And then again, I want to see if I can reduce it. So let's see, they're both divisible by 3. 21 divided by 3 gives me 7. 24 divided by 3 gives me 8. So my constant of variation is 7/8. My equation is y equals 7/8 x. So if you don't have that, fix yours, pause the video and fix it, and then come back. All right, the next page has an example. So pause the video, and read the directions. So the graph shows the number of cubic feet of water used over time. So water used and time at a water park that is open during the hours in the table. So these are the hours that it's open. At this rate, how many cubic feet of water would be used at the water park on a Sunday? So we're going to go through A, B, C, D, answering each part of the question, and that will help us answer how much they use total on a Sunday. So part A, what is the unit rate in cubic feet per minute? Pause the video and see if you can figure it out. So a unit rate is the same thing as our constant of variation. Those are two different ways of saying the same thing. So we do it just like we did our graphs above. I'm going to choose this point because this one, I think it might be 25, but I'm not 100% sure. So I'm going to do 150 divided by 6 and reduce it. So I get 50 over 2. Oh, I can reduce that some more. And I do get 25. So my unit rate is 25 cubic feet of water per minute. That's my unit rate. Cubic feet per minute. Perfect. Letter B. What is the unit rate in cubic feet per hour? So now we need to convert our 25 cubic feet per minute, use 1 minute, into cubic feet per hour. So you guys need, when you do the problems, you need to write this blank down with the units so you know what you're trying to get to at the end. So I need to convert from minutes into hours, which means I'm going to multiply by a conversion factor. And my conversion factor is always going to be a ratio or a fraction that have equal amounts. So if I'm trying to go from minutes into hours, I need my minutes to go away, so minutes are going to go on the top so that they cancel each other out, and hours on the bottom, which is a good sign because I have hours on the bottom over here as well. So now I need to think about how many minutes and how many hours are the same. So 60 minutes, 1 hour. Now I get my calculator out. And I do 25 times 60. Go ahead and do that. Is 1,500. 1 times 1 is 1. So you can leave it like this, or you can write 1,500 cubic feet per hour. Either one is great. So your unit rate and your constant of variation are the same thing. When it asks me to write an equation for the number of cubic feet of water used in X hours, this is just telling me which unit rate to use. I want to use the one that's in hours, so I'm using this one. So my equation is y equals 1500x, that's my equation, and use it to solve the problem from way up at the top. So the problem was, how much water is used at the park on a Sunday? So I need to know how many hours is the park open on a Sunday, from noon to 6 p.m. is 6 hours. And it uses 1,500 cubic feet per hour. So 1,500 per hour times 6 hours, put it in your calculator. And our hours are gone if you guys are interested for the units, because I'm doing 1,500 cubic feet per 1 hour times 6 hours, right? So I don't have hours anymore, I just have cubic feet. Last one, letter D. How many cubic feet of water would be used at the water park on a Tuesday? So I want you to pause here and do it. So we can still use our equation. And on a Tuesday, let's see how many hours the park is open on a Tuesday. So Monday to Thursday, 11 to 7:30. 11, 8.5 hours. Put it in your calculator. 12,750 cubic feet of water. All right, guys, thanks for watching. Have an awesome day.